So now let's look at the first type of knowledge. How do students develop understanding, which is the declarative? It's a relatively simple concept. We sort of all probably know it. So knowledge is the memory. Remember, knowledge is all about memory. Is individual pieces of knowledge about concepts. So you understand theorem 1, theorem 2, you understand programming concept 1, programming concept 2. So these are procedures, facts, all the things you have in your head, and a network of connection between them. Okay, so there is a body of knowledge. How much do you know? All these nodes in your system, all these knowledge, individual pieces of knowledge. And you know there are many people who have so much knowledge of all kinds of trivia. They know about all kinds of stuff. But there's another aspect which is called the depth or richness of knowledge, which is the number and nature of connections between these nodes. So if you consider each knowledge piece as a node in a graph, then how much connections you have in this graph is also part of your declarative knowledge, because that's when you see this knowledge is relevant to this knowledge, and these two knowledges can be combined to create another knowledge, etc. And there's been studies done that the novice and expert's knowledge organization differs in two aspects. One is, of course, the vastness of the knowledge network. The expert has just too much more knowledge. But in the degree to which the knowledge is connected, that is sparse versus dense. So the expert has dense connections between the different nodes that he or she may have. And the novice just has far fewer connections, understands various facts the person has done. So you can see a younger person knows a lot of things, and you ask that particular thing, table of 3, and the person, table of 10, person will repeat, or some other thing you will repeat, some theorem you will repeat, but saying how theorem 1 connects to theorem 2 and how you can use theorem 1, theorem 2 together to solve something, that is the richness of connection between them, which builds with experience and practice. And how meaningful are those connections is also something that is there. So they've done studies of the brain and the knowledge network, modeled it to understand that. So what the key point is that when we are teaching students to develop this procedural knowledge, that is knowledge about understanding, we should help them develop not only the knowledge base, which is all the facts and theorems and all the other things that we want them to, facts and figures and tables and graphs and all that, but also connections between them. How do they relate to other knowledge that the student has? And that's where I think we as teachers often are not we are not able to facilitate that. It's a more challenging thing. Teaching concepts which they can learn just by themselves is a relatively easier problem. You take some knowledge item in isolation, you teach the person learns it, remembers it, memorizes it, and is there in the knowledge, long-term memory. But it's not still useful knowledge. So you need to show connections, and that's much harder. So that's where there is often a trade-off, and that's which you may have faced. You want to teach a lot, and therefore you will not have time to teach about connections between the different knowledge pieces. Or you can teach fewer concepts and talk about how they integrate, how they mix with each other, and what are the connections. Right? So our goal is twofold. Knowledge base, in any course that we are going to teach, we have to develop a knowledge base, a vocabulary, concepts that they must learn. But I'm talking only about the declarative portion. The skill portion we'll talk about. But even in that declarative, they must also understand the connections between the concepts. So, as I said, as I'm stating here, my personal bias is instead of covering a lot of concepts, it is better to consider fewer concepts but better interconnection. Okay, but that's my personal bias. But as I said, the goals for the declarative knowledge development among students is twofold: the knowledge base as well as the connections between the knowledge nodes. Okay, so that's the declarative knowledge, understanding, conceptual knowledge that we all are so fond of teaching and we all want our students to learn. We sort of often question them and so on. But the other portion, other side of knowledge, other type of knowledge, which is about skills. So, how do students develop that knowledge? That's also knowledge, procedural knowledge. That is skills. How do they develop these skills? Skill of writing, solving math problems, writing programs, designing, building a circuit, or about building a machine, a car, or what have you, right? So, for any of these things, so first principle here is that to develop any skill, mastery in a skill, something to do something, students must acquire component skills, because any complicated thing is like if you want to build a system, build a circuit, you first need to have a board and then different chips and how do you connect. So you need to have different components are going in there. You just don't build the whole system together. You always build it in parts. So components, and for those you need those skills to build those parts. So this is what is called component skills. And you have to practice integrating them and know when to apply what they have learned. Right? So that's our goal. Let them learn component skills, all the skills, small skills that are needed for students to do the bigger skill. Practice integrating them for the more sophisticated skill. And then they also need to learn, which is more in the declarative world, but nonetheless conceptual world, they need to understand when to apply what. So developing ability to do complex tasks will therefore require development of component skills. That is, the student is comfortable doing the subtask. You can't ask a student to do a complex task when he or she is not comfortable doing the complex task. Then practicing and integrating them effectively and learning how to transfer this knowledge or apply this knowledge. Okay? I've given the reference where you can read up more about it. So if students are weak in critical component skills, then the overall task suffers. That is well established. And so for developing component skills, you have to decompose the bigger complex tasks that you want the students to learn how to do. Right? You have to identify, you have to then identify the skills needed to execute the subtask. And this is where sometimes us teachers, because we've been practicing them for a long, there is something called expert blind spots. So we say, hey, look, you do this task, what's so complicated? We don't understand, often these are the expert blind spots, that there are component skills that the student needs to have before he or she can do the task that we are asking. So those are expert blind spots. We have to overcome that and okay, you need to understand that. So suppose you making a student, you teaching a student how to make a presentation. And suppose the thing is the presentation is to be made in PowerPoint for a student who's completely new. Now you can tell him the concept of presentation. There ought to be a title, there ought to be this, there ought to be a theme. You must talk about what you are going to present about. You must focus on key points. You must summarize, etc. But if you ask them to now make the presentation, the student is likely to suffer on PowerPoint because he has never used it. So while you're teaching this larger concept of how do you organize your presentation, if the student is completely new, you please make sure that the component skill, namely that of PowerPoint, is quickly taken care of, because putting them together is very complex. There is a lot of cognitive load, and students can't handle it. So even small amounts of practice for component skill can vastly improve performance of overall task. So there's some experiment in the paper they did about students were learning some mathematical concepts using Excel. Now you can do a lot more, right? Change the numbers and see what is happening. And they realized that the students were struggling in Excel, the Excel formulas and so on. So while your goal was to teach the mathematical concepts so they can learn well and they can apply them to create some new formula, they were struggling in Excel. So a little training on Excel and then you get onto it, and this learning was significant, right? So it's important that whatever you're teaching them, that they must have the component skills either from before or you have